The early galaxies discovered in the depths of space by the James Webb Telescope provide significant challenges for scientists due to their size, brightness, and mass. In specifics, it seems improbable that such massive galaxies would have existed so soon after the Big Bang. That's not all, though. The pace of expansion of the universe is actually far higher than it should be, according to Webb's observations on the perplexing deviation of the Hubble constant. However, what is the explanation for this enigmatic disparity? Simply said, by the knowledge that the cosmic worlds are merging, and that our universe is only one among many. The concept of an official research study, whose findings are more in line with observations in space than the conventional cosmological model, is what initially appears to be the invention of a creative science fiction author. No, the James Webb Telescope won't be useful. We will never be able to see past the boundaries of the observable cosmos, no matter how strong our space telescope is. Our cosmic field of vision is defined by the spherical space surrounding our Earth, since the cosmos is isotropic, meaning that it always appears to the viewer in the same way, regardless of the direction of observation. The universe's expansion is also the reason for our limited perspective of the stars. But the universe is not growing into an already existing space. Rather, the space is growing larger and larger. Therefore, we cannot simply multiply the age of the universe by the speed of light to find the distance to the observation horizon. This is because the distance is actually 46.3 billion light-years, not 13.8 billion, when cosmic expansion is taken into consideration. The far-off structures that now delineate our sight barrier were actually only 40 million light-years away when they first discharged their light. But we don't know what processes are going on there right now, or what's out there beyond the observable universe, because the light that is currently coming from there just can't get to us anymore. We do know, or at least we believe we do, that the cosmos started 13.8 billion years ago. This suggests that the so-called singularity, an unfathomably hot, dense point, was where it all started. Eventually, space, time, and matter all came together from this metaphorical primordial seed, and the universe started to expand. This expansion, known as cosmic inflation, happened in a very short period of time and was not at all gradual. In specifics, during this ridiculously brief period, the cosmos grew by a factor of 10 to the 26th power. In other words, it suddenly grew 100 quadrillion times larger than it was before. So far, so widely acknowledged. However, cosmic inflation also poses at least two important queries in the same sentence. What caused the universe to begin growing so quickly and enormously, and why did it eventually come to a halt? Is there more than one universe? The so-called inflaton field, to put it simply, is the peculiar field that researchers believe has had or still has a major impact on cosmic inflation. Depending on its condition, this field has the ability to make the universe expand and expand incredibly quickly. If the inflaton field had been in a false vacuum soon after the Big Bang, it might have switched to a real vacuum or another lower-energy false vacuum due to random quantum fluctuations, i.e., small random variations in the values of the basic particle fields. For clarity, a region with low energy, which need not be zero, is referred to as a real vacuum in this context. There simply cannot be a state in which this region contains even less energy, as that would be a fake vacuum. In reality, a true vacuum can very well include both mass and energy. According to the theory of inflation, this indicates that the cosmos grew exponentially as a result of the inflaton field state shift. However, the field also released energy in the form of matter and radiation when it changed from one vacuum state to another. This is significant because the inflationary expansion phase was slowed down and terminated by the matter that was now present in the universe, allowing the universe to expand at a normal pace. Nonetheless, other studies have also encountered issues with this widely held belief, and they are by no means new. The idea that cosmic inflation has not actually stopped completely was first proposed by American physicists Paul Steinhardt and Alexander Vilenkin in the 1980s. In other words, individual bubbles may emerge as a result of the random quantum fluctuations, where the inflation field would take on the ideal value to stop the inflation. But elsewhere, and here's the important part, cosmic inflation might go on uncontrolled. Put another way, the The universe as we usually think of it is really only a bubble-shaped subregion where our globe has been able to develop. On the other hand, if this is indeed the case, there must be further bubbles where other universes have emerged, which is why this hypothesis also goes hand in hand with another fascinating observation. Therefore, in this view, the Big Bang would just mark the beginning of the inflationary pause in our cosmic bubble, not the beginning of everything. There is actually no beginning of anything in this scenario. Instead, there is just eternal inflation from which bubbles of new worlds are continually separating, such as colliding newborn universes and new theory. The insights drawn from the cosmic bubble model are indeed quite intriguing. However, is there a means to monitor or perhaps communicate with the other worlds, given that it actually corresponds to reality? Since the inflationary expansion of space keeps humanity inaccessible from the other universes, most scientists say that the answer is definitely no. It should be mentioned, nonetheless, that not all experts share this belief that worlds are inaccessible. On the contrary. In fact, the investigation conducted by the scientific team headed by Jan Amjayaran and Yoshiyuki Wadabiki concluded that our universe was initially created by fusion with another cosmos. Essentially, we must remember that one of the biggest study riddles of our day is still the universe's accelerating expansion. Let's simply examine the perplexing variations in the Hubble constant, which represents the current expansion rate of the cosmos. The Hubble constant is 67 chem/s per megaparsec, if the equivalent value is calculated using the cosmic background radiation. However, the Hubble constant abruptly increases to 73 chem/s per megaparsec when the expansion rate is calculated using supernovae, red giants, gravitational lensing, and variable stars. The James Webb Telescope just revealed that the universe is expanding faster than it should, which is the only explanation for the perplexing mismatch. Webb examined more than 320 variable stars, or so-called Cepheids, to check historical datasets for inaccuracies. Based on this, he proved that the seemingly inconceivable variations are real. But the history of this fact is as unclear as the answer to the issue of what is causing the cosmos to expand more quickly. Experts have hypothesized dark energy, an enigmatic component that opposes gravity, as the explanation for the cosmic speed boost and a way to reconcile it with the conventional cosmological model. To now, this hypothetical energy source has only been identified on paper by its ability to accelerate space expansion. It has not yet been directly confirmed. As a result, some astrophysicists occasionally seriously doubt the existence of dark energy and instead search for other explanations for the universe's dynamics. But according to the previously cited study by Amjayaran and Wadabiki, these choices can also be incredibly unexpected. The paper, which was published in the Journal of Cosmology and Astroparticle Physics, concludes that the ongoing merging with other universes may really be the cause of the universe's expansion. Furthermore, merging with the so-called infant universes can even better explain the gathered data than the conventional cosmological model, according to Amjayaran. The idea that several universes interact with ours is not new in theory. However, the mathematical model that the scientists employed to examine the potential impacts that such a situation would have on our planet is novel. Merging with other universes might increase our own volume, which our instruments might interpret as cosmic expansion, according to the researchers' estimates. The researchers also calculated the rate at which the universe would expand in this scenario and discovered that, in the end, their findings are more in line with real-world space observations than the conventional standard cosmological model. Additionally, the authors deviated from the notion of the previously mentioned inflation field by addressing the issue of cosmological inflation in their study. The scientists instead proposed that our young universe was engulfed by a larger parent universe as the reason for the extremely rapid expansion of the early cosmos. In light of this, the researchers speculate that once our universe absorbs itself, it keeps colliding with other newborn universes and engulfing them as well. The experts are now working on a series of studies to reveal the microwave background's hidden features in order to test their groundbreaking theory. But whether the baby universe idea or the well-established standard model is more appropriate for explaining the universe's ongoing expansion will ultimately have to be demonstrated in the future. Yoshiyuki Wadabiki is basing all of his aspirations on the information that the Euclid and James Webb telescopes will eventually gather. At this point, we are placing all of our expectations on the new subscription that you should be obtaining. Please give us a thumbs up and subscribe right away to ensure you never miss another one of our videos.